So let's see one more problem called reader writer problem. Okay, so again we'll use semaphore solution to reader writer problem. Okay, so there are two processes, reader process and writer process. Here it is sharing a file, a common file. This file is shared by multiple processes. Okay, so what are the operations performed on file? That is read operation, it will read the contents of the data, or write operation, that is it will modify the contents of the data. Okay, suppose that if there is a account balance of 500. Okay, and this particular account balance of 500, initially it is 500. So there are transactions so that this 500 will be modified to 1000, and then some decrement is done, 800, so 50 and 1500, something, some money will be added and some money will be subtracted. Okay, so deducted, added and deducted. So when initially, even if you want to write the data, that is modify the data on a shared file, first you need to read, then you write, that is modify the data on the file. Okay, so but here there is a condition. What is that particular condition? One, this particular reader process does not modify the data. There will be no modifications are there. That means multiple processes, that is P1, P2, P3, P4. If there are multiple processes that wants to read the data, that is performing read operation, they can perform. That means multiple processes can read the data, but when writing is performed, we need to check that two or more processes. Okay, so that is only one process can modify the data. Okay, can modify the data. That means there is a condition that if you use a variable called read count. Okay, if read count equal to 1, okay, that means there is process P1 has read the file. Okay, has read the file. And if P2 also read the file, that means read count will become 2. Read count will become 2. You cannot, at this particular point of time, if read count equal to 2, then you cannot allow any one of the process to write, perform write operation. Okay, so when multiple processes, that is more than one process has read this particular file, you cannot allow write operation. You can allow read operation, but you cannot allow write operation. That means when a file is read by only one process in the system it is only read by only one process, then that particular process can modify the contents. Okay, so if multiple processes has read it, even that process cannot write the data. Okay, right? So when multiple process has read the data, we disable the write operation. Okay, right? So we'll use some semaphore variables and some integer variables. Let's see those variables, implementation of this one. Okay, so the variables that we have taken here is readrab mutex, it is a binary semaphore, and mutex, which is also a binary semaphore. The values of read write and mutex is 1 and 0 only. Okay, so the operation that is performed are wait on mutex, signal on mutex, wait on readw mutex, signal on read write mutex. Okay, rw mutex. So the implementation is same. You can write wait on mutex. Okay, we'll use a while loop. If while on mutex or read write mutex, okay, rw mutex is less than or equal to 0, then either the process will be blocked or the process will keep on executing that stuck in while loop. Okay, if it is 1, that is mutex equal to 1, we'll decrement the mutex value by 1 and allow that particular process to enter into critical section. One critical section means either it is read or write operation will be performed on critical section. Okay, once this critical section is done, we'll use signal on mutex or read write mutex. So what will happen in signal? We will implement increment operation. Okay, so this is both for mutex and read write mutex, this will be happen whenever mutex value less than or equal to 0, the process keep on executing while loop. Okay, the only process, the first process which will execute this particular mutex will decrement the value 1 by 0. After executing critical section, while it is coming out, what is meant by critical section? Either read operation or write operation. While it is coming out, it will invoke signal operation and implements increments mutex plus plus or mutex plus plus. Okay, that means increment the value of mutex by 1. Okay, so now remember that while we'll see, let's see the code for writing the data. Okay, write operation, it is very simple. Read write mutex is a write operation. Okay, so initially mutex equal to 1, read write mutex equal to 1. Okay, so read write mutex equal to 1 here. Now look at here, if read write mutex equal to 1, then the writer process is a continuously executing process. Okay, do while it is a continuous loop. So while read write mutex, so we need it will decrement the value of 1 by 0. Okay, that means, and it will enter and modify the content. So if it is 500, it will be changed to 1000. Okay, some 1000 it will be added from some 500. Then after modifying it, you have to come out and execute read write mutex. So it will be 0 to 1, because signal will increment the value by 1, so that the next process will modify the data. Okay, the next process, suppose that this is p1 which is modifying the data. Once it executes signal, the p2 process will may modify the data. So this again, wait is providing mutual exclusion and signal is providing progress and bounded waiting. Okay, progress and bounded waiting. This is a writer process, that is code for writing the data is easy. But now let's see the read process. Okay, the read process, there are conditions. What is the condition? When this particular read count value is greater than 1, you cannot allow modification of data. So here we have to use both mutex and read write mutex also. We need to disable the read write mutex value when multiple people are reading that particular thing. So let us see, p1 is a process who wants to read the data initially. Okay, so what he has to do, initially read count equal to 0, mutex equal to 1, read write mutex equal to 1. Okay, right? Now look at it, wait on mutex, so that no other process will execute mutex, because it indicates that one process is executing that particular critical section. It started executing critical section. So if p2 p3 any process try to invoke wait on mutex, they have to wait in the while loop, they have to wait. Okay, now after executing this one, it increments the read count by 1. So because one process has executed it. Okay, then now if read count equal to 1, yes, read count equal to 1, then we need to disable read write mutex to. Okay, we need to disable writing operation. So 1 to 0, we need to disable write operation, because this particular p1 may wants to modify, we don't know. Okay, then after that we need to give signal, so that mutex value will become 1 and the process will read the data. P1 is reading the data. So p2, okay, after reading the data, the process decides to modify the data. Okay, the p1 decides to modify the data, but at this point of time P2 decides to, P2 also decides to modify the data, which is already read, and decides to modify the data. So read count will become 2. Read count will become 2 and P2 decides to modify the data. But the problem is here P1 disable the read write mutex to 0. So if it has to execute, wait on RW mutex. Okay, but the value of RW mutex is 0. So it will stuck in while 0 less than or equal to 0. What is 0? Read write mutex value. So it will be stuck here until and unless P1 come out. Okay, P1 execute this portion. P1 execute this portion and release this particular signal. It will be P2 is not allowed to write. Okay, so that's why we have written if read count equal to 1, then wait on read write mutex to 1 to 0. Okay, now after reading, P1 wants to write the data. So what P1 will do, again P1 executes mutex to 1, so it will become 1 will become 0. Okay, then it will decrement the read count value. Okay, decrement the read count value. So assume that P2 is not read, so read count value is only 1. Okay, P1 is the only one that is read, so 1 to 0. Okay, right, 1 to 0. Then it will release, because it doesn't want to write, it will release signal. It will release signal, so that read write mutex equal to, what is the value, 0 to 1 again. Okay, 0 to 1 again, and it will release the mutex value again, 0 to 1. Now again we come to the original thing, that is read write initial values, read count equal to 0, mutex equal to 1, read write mutex equal to 1. Now at this particular point of time, if P2 wants to write the data, because P2 already read it and released it, P2 wants to write the data, then it is a chance for P2. P2 has to execute this code. Okay, P2 has to execute this code. It immediately executes P2 execute, because read value equal to 1, it will decrement to 0. It performs write operation, and after writing it release the read write mutex value and increment 0 to 1. Okay, so read operation is very important here. Okay, so what is condition that we did? After reading the data, we disable, if read count equal to 1, immediately we disable the write operation. Okay, disable the write operation and read the data, and at the time this particular read count, okay, the process continues to decrement the read count value. When this particular read count will be enabled, only when the read count equal to 0. Only when the read count equal to 0. That means P1, P2, P3 initially read the data, so read count value equal to 3. Okay, so when P1 execute this one, read count value will become 2. When P2 execute this portion, read count value will become 1. When read P3 execute this portion, okay, read count value equal to 0, then the P3 may have, and P3 will release will increment the signal value of mutex. It invokes signal and increments the RW mutex to 1, and that allows the next process to execute write operation. That allows next process to execute write operation. This provides progress property. Okay, this provides progress property. So signal provides progress and wait provides mutual exclusion. Okay.